Hello, everybody. Hope we're all staying happy and healthy. So we're going to pick it up where we left off with the trig section. So far in trigonometry, we've talked about trig identities, we've talked about trig expressions, we've looked at how we solve taking sine and cosines of certain values, and we've done trig equations. So now we're going to kind of combine everything together and take a look at graphing trig functions. So when we go to graph these trig functions, what we're going to find for sine and cosine functions, they have a lot of similarities, and their graphs are gonna look very similar as well. Tangent's gonna be a little different, but we're gonna stick with sine and cosine for now. So when you go to graph a sine and cosine function, what you end up getting is something called a periodic function. What a periodic function is, it is a function that repeats over a specific period. So what happens is once you get from some value to another value, that identical function will just happen again and again and again. So the graph follows the same pattern over and over and over. For these graphs specifically, the curve oscillates, meaning it makes this wave pattern where it goes up and down and up and down about some line that cuts it in the middle. And in that wave pattern, we have certain pieces of information that we're always looking for, such as the amplitude, which is the distance from the middle of that wave to the highest point or the lowest point. And in these graphs, we're going to refer to that as the sinusoidal axis. And some of you might already be familiar with this information. Some of you may have taken physics before, where we study waves rather closely. So this might be some information that you've already seen, so that's great. For everyone else, let's just see what happens when we take a look at sine and cosine graphs. So what I want to do to start is I just want to make a nice table of values, right? Because whenever we're trying to graph something, one of the easiest things that we can do is just make a table of values and see what the points indicate is going to happen, right? So if I take a look at my unit circle and I want to graph the function of y equals sine x. So let's pick a couple of key x values and then see what their y values are. So if I plug in 0 for x, so 0 is here on my unit circle, so the y value is 0. Pi over 2 is up here, so sine of pi over 2 is positive 1. Pi is over here, so the sine of pi is 0. 3 pi over 2 is down there, so the sine of 3 pi over 2 is negative 1. And finally, 2 pi, my graph restarts, right? Does a full rotation, so we're back to 0. So if I were to take these 5 points and plot them on a graph, what I'd find is that it looks like this: 0, 0, pi over 2, pi 0, 3 pi over 2, negative 1, 2 pi 0. Okay, and then from this graph, we want to be able to pick out some key information. So I mentioned amplitude earlier. Again, what amplitude is, it is the distance from the highest point of our graph. So when we're talking about these waves, we call the highest point the crest, or the lowest point of my graph, which I believe is spelled trough. It's the distance from those points to that middle, right? So from my crest to my middle of my graph, or from the trough to the middle of the graph. And the way that we find that is we can calculate it using the highest point of my graph, take away the lowest point of my graph, divided by 2. And it's always that absolute value, right? We don't care about positives or negatives. All we care about is the magnitude of the distance. We don't care if it's up or down, right? So we're going to take that answer. So in this case, negative 1 minus 1 is negative 2 divided by 2. So when we take the absolute value of that, we get positive 1. Okay, another piece of information that we're looking for with these graphs is the period. When does my graph reset? And if you think about the unit circle for a second, right, when does this pattern happen or restart? It restarts when we do one full rotation, right? So when we start here at 0 and we go all the way around and we get back at 2 pi, we get back to that same point. So the period for these sine and cosine graphs are 2 pi. So the time it takes to complete one full wave, right? If we look at my graph here, we go from y equals 0, and then we go up, 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 up to 1, and then back down to 0, and then down to negative 1, and then back up to 0, and then all of a sudden, we're restarting that pattern where we're going from 0 back up to 1. To do that, it took us from 0 to 2 pi, so that is our period. And then the sinusoidal axis of this graph is a line, right? So whenever we're talking about an axis, I'm not talking about a point. So it's not good enough just to put a number value. I need to see an equation, right? So the sinusoidal axis of this graph is y equals 0. It's this line that cuts my graph in half. Okay, the maximum value of the sine and cosine graph, just the basic one, the maximum value is positive 1 and the minimum value is negative 1. So what does that mean for domain and range? Well, domain is all possible values of x. So what are the possible values of x here? Is there any value of x that we can't plug into this function? And the answer to that question is no, right? When we're taking the sign of some number, we can take the sign of any number. There's no real number that we're not able to take the sign to the cosine of. So for the domain here, we're going to get x such that x is an element of the real numbers. Now, the range, on the other hand, if we take a look, what are the possible y values? Well, all y values for sine and cosine, or at least sine graphs, are going to be less than 1 or greater than -1. So that is our range. So it's y such that -1 is less than or equal to y, which is less than or equal to 1. But y is still a real number. Now, what about my x-intercepts here? When does this thing hit 0? Well, it hits 0 an infinite number of times, right? Because this thing is periodic, meaning it's going to repeat over and over and over again. It hit 0 here at 0. It hit 0 again at pi. It hit 0 again at 2 pi. It'll hit 0 again at 3 pi and 4 pi and 5 pi. So what ends up happening is my x-intercepts here are going to be 0 plus pi n, where n is an element of the integers, right? So it's every pi units, it hits 0 over and over and over and over again. Okay, so let's take a look at cosine now. So cosine, again, really similar. That's weird. Cosine, really similar to sine. It follows a lot of the same patterns, but something will change here. And what we'll see is that when we're doing the sine, we're always looking at the y values of my unit circle. But for cosine, we're going to be looking at the x values, right? So again, we're using radians, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I go to fill in my table of values, the cosine of 0 is the x value of my point in my unit circle, so we get 1. And then pi over 2 is 0, and pi is -1, and 3 pi over 2 is 0, and 1. What we notice is that we still have this pattern, right, where we started with a 1, and we end up going back to the 1. So when I go to graph this thing, it looks like this, where we have 0, 1, pi over 2, 0, pi -1, 3 pi over 2 is 0, and 2 pi 1. And what you'll notice is that the cosine curve actually looks really similar to the sine curve. And in fact, it is exactly the same curve, just shifted to the left pi over 2 units, right? So if I took this, shifted to shifted to the left. So if I took this pi over 2, or this 0, or the point back here, and I shifted them all to the right pi over 2 units, what I would get back to is I'd get back to my sine curve. And that's just kind of the nature of sine and cosine, right? And we could prove that, right? We could look at our identities, our sum and difference identities, and say, well, if I took the sine of c, I don't know, I put the O there, c minus pi over 2, and if I were to apply my identity, I would get the cosine of c, right? So we've talked about these identities, these difference identities before, and we've proven this in the past, but this is like a visual representation of that. And again, we can find the same information from sine graphs and cosine graphs, so the amplitude, the period, all that stuff. And what ends up happening is that it's all the same, right? My amplitude for my cosine graph, again, my highest point is up here at 1. My sinusoidal axis is at 0. So my amplitude is 1, right? The time it takes to repeat the pattern, so to go from here at 1 and then go back to y equals 1 is 2 pi units. So again, it has a period of 2 pi. Maximum value is still +1, minimum value is still -1. And my domain and range is also the same, right? My domain is x such that, x such that x is an element of the real numbers, right? It's all real numbers. And my range, y, such that -1 less than or equal to y less than or equal to 1, right? Y is between -1 and +1, and y is a real number. Now, the x-intercepts are a little different because we've shifted it pi over 2 degrees. So now, instead of being at 0 and then plussing pi every time to get to the next one, it starts at pi over 2, and then it pluses pi n, where n is an integer. So it's a little different, just slightly, but the characteristics of the graph are all the same, and that makes sense because, like we just said, right, this graph is the sine graph shifted a little bit, right? So they are the same graph, so it makes sense that a lot of their characteristics are exactly the same. Alrighty, so let's take a look at a couple of things. So how do we graph these things? That's what we're going to get into. And the first thing I want you guys to consider, to think back about, are transformations. So you can use transformations to graph any graph, not just these trig graphs we're going to talk about, but really like any graph you've ever looked at. You can use the transformations of what is called the parent graph in order to help us figure out what the new graph is going to look like. So for the graph of any function, we can consider the transformation on the parent graph to help determine the new graph looks like. So where this is our transformational form, where we have y equals a times some function f, x, I'm just realizing there's a little typo in there right now. Give me a second. So y is equal to a onto some function f, x minus h over b plus k, where a is my vertical stretch. So it takes my graph and it stretches it up and down vertically. It takes my y values and makes them a value that is a times taller. B is my horizontal stretch. It's going to take my graph and shift it horizontally. H is my horizontal translation. It's going to take my graph and it's going to shift it left and right. And K is my vertical translation. It's going to take my graph and shift it up and down. So what we can do with that is if we have some function, whether that's a polynomial, an exponential, logarithm, trigonometric, whatever the case may be, we can take the parent function. So for example, if I was talking about a quadratic, the parent function would be y equals x squared. And what we can do with that is we can apply transformations like y equals 2x minus 3 squared plus 4. And by using these transformations, like the vertical stretch, horizontal translation, or vertical translation, we can graph our new function. So as long as we know these pieces of information and we know what the parent function looks like, we should be able to graph any function. Well, fortunately, we just talked about what cosine and sine look like, right? We have the graph of y equals sine x, and we have the graph of y equals cos x. So what we can do is we can use these transformations to help us figure out what the graph of any sine and cosine, even if we do start changing the values. So here's my sine and cosine basic graphs right here. What you'll notice is that the b value here is a little different than the b value from before, but this b value that we put in here is the reciprocal of the horizontal stretch, right? So it's 1 over. So let's just stop here and just take a look at what happens when we start changing these values, okay? So here's a function, or my graphing, my online graphing tool here. So let's take a look. Let's take a look at the function y f of x is equal to a sine. Actually, just a second before I do that. What I want to do is I want to establish some constant, some term in here. So we're going to say the constant name is a, and we're just going to give it the value 1 for now. Okay. So what I want to do is, let's see what happens when I change my vertical stretch of my graph. So let's take f of x is equal to a sine of x. And right now, a is equal to 1. Sorry, a times sine x. There we go. So right now, a is equal to 1. So this is the graph we should be used to seeing, right? Where my a value is 1, so it goes from 0 up to 1, back down to pi, down to negative 1, and up to 2 pi. So let's see what happens when I change my a value. So what I'm going to do is I'm going to animate it. I'm going to take that a value, and I'm going to start at negative 4. And I'm going to bring it all the way up to positive 4. And let's see what happens as that a value changes. So for right now, here is negative 4. And what you'll notice is that my zeros are still at the same place. I still have this point here at 0, 0. I still have another one here at pi 0 and 2 pi 0 and so on. But my y values, instead of going from 1 to negative 1, now go from 4 to negative 4. And something else happens too. With y equals sine x, we went from 0, 0 up to 1, but now we're going down. So what's happening here is when we have a negative vertical stretch, right, a negative a value, it's going to take my graph and it's going to flip it vertically. And then how much it goes down by is going to be affected by the value of that a. So if it's going down by a factor of 4, instead of going from 0 to positive 1, it's going down from 0 to negative 4. So let's see what happens when a goes from negative 4 to negative 3. Okay, just a sec here. So from negative 4, maybe, negative 4 to negative 3. Right? So we'll see that my graph now has an amplitude of 3, and it's still going from 0 and is going down. And then when I go from negative 3 to negative 2, it gets a little shorter. Still going down though, negative 2 to negative 1 gets a little shorter, right? And now it looks like it's the same height as the original graph, just flipped upside down. 0 doesn't really do anything. And then as soon as I get back to 1, there's my original graph. And then when I go to 2, it gets taller, and then 3 gets taller, and then 4 it gets taller, right? So again, if we look at that happening, so it starts off tall and upside down, and then what's going to happen is eventually it will flip back and stretch back out. All right, so now let's see what happens when I take this graph and we move the placement of A. So instead of having A outside of my sign, let's put A inside my sign. Okay, so now it's in the place of B. So let's see what happens here when I start to change the value of A. So again, let's go from negative 4 to 4, and let's see what happens. So what's happening here is now there's still this thing where my graph got flipped, right? We started at 0, 0, and we're going down. We're not changing the y value. The y value is still negative 1 and goes up to positive 1, so it's still as tall. But what is happening here is my graph is repeating more often, right? So my repetition here happens when I get to pi over 2 as opposed to 2 pi. And then what's going to happen is as my b value gets larger, or smaller, I suppose, absolutely smaller. The sign doesn't really matter. What the sign will do is it just flips it, but the absolute value, the magnitude of it, as it gets smaller, my graph gets wider and wider and wider until eventually I get to 1 and I'm back to my original graph. And then as that number gets larger and larger and larger, my graph's going to compress. All right, so again, if we see this happening, going from negative 4 to positive 4, as my b value the magnitude gets larger, my graph gets smaller and smaller and smaller. Okay, so if I do the same thing for the h and the k values, so again, let's change my function to, instead of multiplying by a, let's subtract a, and let's animate that and see what happens. So now I'm looking at what happens when I change my h value, right? So it looks similar, but notice that I'm not on the point 0, 0, right? I'm starting at some value over here, right? And then as I animate it, as the a value gets larger and larger and larger, the h value gets larger and larger, all that's really happening is my graph is shifting to the right by a unit, right? And then if I do the same thing with the k value, so if I take my function and I take the a out of the brackets and I add it on at the end, again, what should happen here is that my graph starts way down at negative 4, and then as the k value gets larger, my graph shifts up. The shape of it doesn't change, but it'll shift up until we get all the way up to positive 4. And so let's take a look at some of these things. So k is our vertical translations. What that does is it moves my graph up and down. Positive will be up, negative will be down. And our sinusoidal axis, the axis that cuts my graph in half, is always at y equals k. So that's just that halfway line. Okay. The sinusoidal axis only exists for sine and cosine because tangent's a little different. H is my horizontal translation. So as we noticed in the little animation there, what H will do is it'll take a graph and it'll shift it left and right. Notice that in our equation here, it's x minus h. So it's always that opposite sign. Whatever operation is happening to the h, we have to take the opposite sign. B is the reciprocal of my horizontal stretch. So as the B value gets bigger, my graph actually shrinks. It compresses. So what we're going to do is we're going to find our period of our graph, how long it takes that graph to repeat, by taking our original period, which was 2 pi, and dividing it by b. So if I had a b value of 2, that new graph is going to have a period of pi degrees, or pi radians, sorry, because it's going to take 2 pi and divide it by 2, and it's going to shrink it, right? And then finally, our a value is our vertical stretch. And we use this value to find our amplitude. So let's take a look at how we can graph these things. So when I go to graph these things, I think of there being two strategies. So the two strategies that I like to think about are number one, mapping, and number two, just knowing how your transformations are going to affect the graph. I know it's kind of like well, that's not really a strategy, but once you get comfortable with these transformations and you start using them a lot, you're not going to need the mapping idea quite as much. And in fact, it gets to a point where your direct transformations, just doing the transformations, actually becomes more useful because when we go to go from the graph back to the equation, the idea of doing it by using the mapping is going to be very difficult. If you understand the transformations, it's going to make your life a lot easier. All right, so in order to do this mapping strategy, what we're going to do is we're going to make a table. We're going to make a table where the first two columns of my table are the values that we talked about initially. So if I'm talking about cosine, it's these values here. And if I'm talking about sine, it's these values, right? And then what's going to happen is our next two columns in our table are going to be our new x and y values based on the transformations. And what we can do is we can calculate that algebraically, right? We can take our old values and we can divide them by b and plus h, and that'll give us our new x values. And we can take our old y values. I'm just going to put a x o here and y o here, just say the original x value, the original y value. In order to calculate our new y values, we're going to take our original y value, multiply it by a, and add k. So let's take a look at an example. So here's an example here. Graph y equals sine of x minus 90 plus 2. And we also want to talk about the period, amplitude, and the equation of the sinusoidal axis. So my original y value for y equals sine x. So at 0, we're going to do degrees here because the h is 90, right? So that implies to me that it's supposed to be 90 degrees. So my original sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. And then 270 is negative 1. And then 360 is back to 0. So what we get here is we're going to take our x values, we're going to divide them by b, and add h. So we're going to take this 0 degrees, divide it by 1, right? B is 1 here, the number that's in front of my bracket. So a is 1, b is 1, h is 90, and k is 2, right? We get our a, our b, right, our h, and our k. So we're going to take this 0 degrees, divide it by 1, and we get 0, and then add 90, we get 90, right? We're going to do the same thing for all of our degrees. So this 90 here, divided by 1, add 90 is 180, divided by 1, add 90 is 270, divided by 1, add 90 is 360, and then 450. Okay, do the same thing with our y values. So take my old y value. So we're going to take it here in 0, multiply it by 1, and then add 2. We get 2, 3, 2, negative 3. Sorry, that's not right. Negative. My goodness, I'm having a rough day today. Positive 1 and 2. So now, if we take a look, so we knew that our a value, a is our amplitude, right? So if we're being asked to find these pieces of information like amplitude and period and so on, we're going to do that by using our a value of 1. Well, that's amplitude, right? So amplitude is 1. Our b value is also 1, and we know that period is going to be equal to our original period. So for a sine graph or cosine graph, it's 360 degrees divided by 1. So our new period is still 360 degrees. Our horizontal translation, so here my h value was 90. It was positive 90, so it's 90 to the right. and my vertical translation was 2, and again it was positive 2, so it's 2 units up. Okay, my domain for these graphs are always going to be x, such that x is an element of the real numbers, right? Because there is no value for x that we can plug in and not get an answer. My range, on the other hand, will change because it is stuck between that highest and lowest point. We have to consider that. So for this one, my range is y, such that 1 less than or equal to y less than or equal to 3. Right? Those were the highest and lowest points on my graph. And then y is still a real number. And then my sinusoidal axis here, the nice thing is once you know k, because the sinusoidal axis of my sine and cosine graphs were at 0, right? As soon as you shift that up 2 units, it's going to be y equals k. So in this case, y equals 2. Okay, so let's graph this thing. So if I have a point here, 1, 2, 3, and okay, so here's my graph. One thing I do warn against is whatever scale you pick for your x-axis, make sure you keep it consistent. Like I don't want to see anyone go like from 0 to 180 and then 270 and then 360 and so on, where this first jump was 180 units because maybe that's where my graph was supposed to start. But then this next jump is 90 units, right? That we can't do that. That's not okay because if we're going to pick a scale along our x or our y axis, we got to make sure that it is consistent, right? So let's get rid of that for a second. So in this case, my scale, I'm going to use a scale of 90 degrees because that's how my graph is shifting. Okay, and then I'm going to use a scale of just 1 unit along my y-axis, and then start to plot my points. Right, so we have a point at 92, 183, 272, 361, and 452. And if I attach my points, I get a graph that looks something like this. Okay, so let's try another one. So maybe at this point you might want to consider pausing the video and trying this one yourself and then checking the answers. But once you're ready, restart it and we'll go through this together. So again, what I'm going to do here is I'm going to take a look at my cosine graph, so my original function for these x values. And in this case, it's not giving me any indication up here that I have to use degrees or radians. So I'm going to use radians just to practice. So I'm going to take a look at my cosine values. So my original y values for the cosine graph are 1, 0, -1, 0, 1. So then what we're going to do with those numbers is we're going to find our new x and y values. And again, this is my original x and my original y here. So to find my new x values, I'm going to take my original x values, divide them by b plus h. The nice thing here is there are no b or h values, so I'm just going to have my original numbers here. So 0, pi over 2, pi, 3 pi over 2, and finally 2 pi. Now my new y values, I have an a and I have a k. So what I'm going to do is I'm going to take this 1, I'm going to multiply it by 3 and then subtract 2. So 1 times 3 is 3 and then minus 2 is 1. Do the same thing here. So 0 times 3 is 0, minus 2 is -2. -1 times 3 is -1. -3. -3 minus 2 is -5. And then again, -2. And then back to 1. Okay, so again, what we're going to do to find these pieces of information like amplitude and period is look at my A, B, H, and K. So my A for this was 3, my B is 1, my H is 0, and my K was -2. So what that means is my amplitude is going to be 3, my period is 2 pi divided by B, which is 1, or in this case 2 pi. My horizontal translation is 0 to the right or left, I suppose. And then my vertical translation is 2 units down, right? Negative vertical translation means we're going down. My domain will not change, right? X such that X is an element of the real numbers. My range, again, lies in between the highest and lowest points for this graph. So y such that -5 less than or equal to y less than or equal to +1, and y is also a real number. And my sinusoidal axis is y is equal to -2. So to sketch this thing, we're going to take these points and plot them. So again, pay attention to what scale you're going to need. Here, we're going from 0 to 2 pi, right? So we might want to jump by pi over 2 on the x-axis. So pi over 2, pi, 3 pi over 2, 2 pi. And on the y-axis, we're going from -5 up to +1. So 1, 2, 3, 4. -5 is down here, and +1 is here. And let's graph our points. So 0, 1, pi over 2, -2, pi, -5, 3 pi over 2, and -2, and finally 2 pi and 1. So my graph looks something like this. Maybe if I can get my graphing skills up to snuff here. All right, there we go. Okay. So one more example here before we call it a day. And this time I'm going to think about this idea of my direct transformations without having to make my table and just kind of consider the transformations and what that's going to do to my graph. So if I wanted to graph this thing here, so this next one has a few more transformations, and we want to state the period, amplitude, stretches, translations, all that fun stuff. So what I want to do first is just say, okay, what are my A, B, H, and K values, right? So my A here is 2, my B is 1, my H is -180, and my K is -2. So from here, we can answer some of these questions. So again, what's the period? The period here, let's work in degrees, and that's what this 180 is implying here. So my period is going to be 2 pi divided by b, or in this case 1, so that's 2 pi. My amplitude is going to be equal to my a value, so 2. My horizontal translation is my h, so that's 180 to the left. And my vertical translation is my k, so that's 2 units down. My domain, range, and sinusoidal axis. So domain is going to be x is an element of the real numbers, right? My range, on the other hand, is y is between. Now let's stop and think about this for a second, right? So we're shifting down 2 units. So right now, before I get to my range, let's take a look at my sinusoidal axis for a second. So my sinusoidal axis is what? It's y is equal to -2. So that's the middle of my graph. My amplitude is also 2. So what that means is if I'm starting at -2, so if I have my sinusoidal axis down here at -2, right down here at y equals -2, from that sinusoidal axis, I go up 2 to get to my highest point, and I go down 2 to get to my lowest point. So what that means is my range is in between -4 less than or equal to y less than or equal to 0. And y is a real number. So from here, what we can do is we can consider the pattern as opposed to the points. So if we think about cosine for a second, so if we think about y equals cos x, right? When we went to make that table of values, it started at 1, goes to 0, down to -1, back to 0, and back up to 1. So the pattern that happens here is the first point we get is the high point of the graph, and then it goes to the middle of the graph, and then it goes down to the low point, and then back to the middle, and then finally back up to the high point, and then the pattern repeats. So what we can do is if we know our new middle, high, and low, and we know where our graph starts and ends, all we have to do is just continue using this pattern to graph it. So what'll happen is this high point will start, normally it starts at 0, but because my graph has a horizontal translation of negative 180, my new high point is going to start back at negative 180. So if I take my graph and I go to graph it, right? So instead of starting at 0, 0, my new high point is back here at negative 180, right? And I know what my high point is. My high point is here at 0, right? My middle is at my sinusoidal axis, and my low point is at negative 4. And then what happens is my period is, I don't know why I put 2 pi for period. It should be 360, right? Because we're talking about degrees here. So 360 degrees divided by 1 is 360. So what's going to end up happening is we go from negative 180 to negative 90 to 0 to positive 90 to positive 180, and there's my full period, and then we just follow this pattern, right? So again, what cosine does is it starts at 1, or it starts at the high, and then from the high it goes to the middle, and the middle for this graph was negative 2, so negative 1, negative 2, negative 3, negative 4. So it goes from my high to my middle to my low, and then back to the middle, and then finally back up to the high point. So there is my graph of cosine. Right, so again, instead of trying to make a table and then algebraically or calculate the values, what we can do is we can use this pattern of high, middle, high, as long as you know what the points are, right? So for my original cos x, the high was 1, the middle is at 0, the low is at negative 1, and then back to 0, and then back to 1, right? For my original sine x, the pattern shifts, right? It starts at the middle, and then from the middle it goes to the high, and then from the high back to the middle, and then from the middle to the low, and then from the low back up to the middle, right? But what ends up happening is the values, again, are the same. The middle is 0, the high is 1, 0, negative 1, 0. So what we can do is we can use the new high and low values, right, to make my new graph, and then shift it left and right according to my horizontal translation, right? So that's it for today's video. Uh, Again, what we'll do is I'll post some questions for you guys to attempt, and then we'll have our meeting on Wednesday. I will see you guys.